In this video, we're going to compare the Llama 370 billion to three versions of GPT-4 plus Opus. In a gamer agent simulation arena, I have written in Python. The objective of the game is for this green circle to receive minimal information about the game, which is only the decisions it has made previously and the distance from food. Here is this pink circle, and make decisions and try to move towards it as fast as possible. We give each agent model total of 50 action steps in each trial to actually win the game, which is plenty of steps. We set the beginning foot distance to 100. And if for any reason the agent is moving away, if it is moving away from the food and if passes max distance, then the game fails. And we allow agents to keep a limited amount of memory of their past action. We will keep track of the results of each iteration for each model. Plus, at the end, we will see the average number of steps they've taken to win it, if they have failed any of the attempts, and the average distance that they have accomplished. So at the end, we will be reviewing the code, but the code files for this project will be, along with the results, will be available at my Patreon. The link is in the description. While the simulation is running, you'll be able to see at the end of each total trials, the models update their stats. You'll be able to see that, plus the game screen in the middle. And at the end, we will tally up all the results and see who's a clear winner. This takes a while. I will now play a sped up video. If you want to skip it, you can actually skip to the next chapter. So without further ado, let's begin. Now that our simulation has been completed, we can actually see the results for each one of the models. For example, we're looking at latest GPT-4. Trial 1 actually was a failure, and we get a failure reason because it's reached maximum steps, and it maintained an average distance of 66.3. In the second attempt, actually, it completed successfully in 25 steps and maintained 62 soul distance. Here is Llama 3, 8 billion. It actually succeeded in the first, sorry, it actually failed. Max steps reached. It's failed the second time around, third time around. It failed all attempts. Let's see, Claude Opus, for example, completed successfully the first run in 36 steps. In 32 steps the next time around. We can also see all results. These results are actually sorted by the minimum number of steps. As we can see, GPT models achieved the smallest amount of steps. We are testing, of course, the latest one, plus 0125 and 1106 variant. But unfortunately, we'll see that sometimes they actually fail, versus, for example, I believe Opus never failed. So we can take a look at this, all results, and then we can actually take a look at the final results, which actually gives us the total trials. Here we see that Llama 8 billion failed all 5 trials, and average distance it maintained was 81. The latest GPT-4 Turbo actually solved the 5 trials 2 out of 5 times. It failed 3 times and maintained an average steps of 35.5 when solving. GPT-4 0125 did actually better, and but failed twice, and 1106 failed once. Opus never failed, and Llama actually only failed once. So I'm going to go ahead and put these into this chart, and then we'll compare. If you are enjoying my projects, consider becoming a full patron, which gives you access to all my code download. Also, check out some of my other tips, such as AI Virtuoso number 3, which allows you to talk to me every month on one-on-one conversations, and also AI Prodigy number 2, which is an available spot in. The benefit of becoming a patron is that you'll be able to download the full code files for any one of my projects. I work on these projects on a daily basis. This will allow you to start and get going with LLM-powered apps really quickly and experiment and build your own apps. Okay, let's take a look. Our first criteria is if a model has failed or not. The next one is the average steps and then average distance. So looking at it, Claude 3 Opus is the clear winner here. It failed 0 times, although it took a little longer than GPT-4 0125 and 1106. It still completed it each and every time. It also scored the lowest average distance in each trial run, maintaining the distance of 64, or at least this was the average, versus the latest GPT-4 actually maintained 67 times. But the next best model was the 1106 variant of GPT-4. It only failed 1 time and it finished with an average step of 25, and its average distance to the food across all runs were 67 pixels. But take a look at this. I mean, Llama 370 billion, this is almost more than an order of magnitude smaller than this rest of the models here, except Llama 3 8 billion. And it only failed 1 time, and it finished all other 4 of its trials with 34-step average, taking 36 actions. And its average distance was a little high, but in any case, I think this is pretty remarkable. Next up is the 01 to 25 variant of GPT-4, which failed twice. Actually, was able to solve it the fastest by taking the smallest amount of actions, and it maintained a very low distance. It's the second best distance, so this is pretty good, except for it failed twice, though. And GPT-4 Turbo, the latest model, failed 3 times. It solved it in 35 steps with 67 average distance. And the 8 billion Llama didn't do good at all. It just failed all of them, pretty much. I'll include a snapshot of this with the code files at Patreon. And if you do decide to become a patron, I appreciate your support. Thank you. Okay, now let's take a look at the code. I actually have 2 variations of this. Game.py actually is a single run. You can select the model, you can do variables such as how much history you want to maintain, beginning food distance, max distance, and max steps, and this will actually run it 1 time for you. So if you want to do experiments like that. But the one that we are really interested in both files, all files here, including the results, will be available at Patreon. But the one that we're really interested in is the multi-turn simulation. We start with a list of models. So you can see that I wanted to actually test GPT 3.5 Turbo, Haiku, and Sonnet, even Mixtral 8x 22 billion, but they just were very bad at following instructions. And especially because Claude's API structure doesn't allow 2 user messages in a row, and they don't have JSON mode. So if they don't return the answer correctly, we are actually sending back a corrective message. And it just was a mess with those models, and they weren't doing very good. Anyway, as you saw, the 8 billion Llama model even failed. So I just kind of left them out. But I do want to say that GPT 3.5 would finish it sometimes. So with Sonnet and Haiku, rarely. And the Mixtral 8x22 was just really acting weird. So that was it just was a bad experience, actually. Anyway, to achieve this, we are actually using the OpenAI Unified, Claude Unified, and OpenRouter Unified classes just to make our life easier. This automatically manages message history and streaming responses and all of that. If you want to find out more about it, you can go to my website and find the video. Here you can type in Unified, and OpenAI Unified video is this one. And I also talk about Claude Unified and Simple Claude Opus Autocoder. Also at my website, which is echohive.live, a link is in the description. You can find and search all my videos. So we set our meta variables for the agent max memory. This is how many words in memory that they can maintain. I actually kept this originally very high, but I thought maybe this was what was leading them to getting stuck in loops. I haven't experimented with many different numbers, but 100 I thought should have been fine. You should give them what they've done at least for 4 or 5 turns of their past actions. Beginning foot distance is 100, max steps is 50, max distance is 150. So they can take up to 50 actions, and then after that, the game is over. Max distance is 150. If they, for some reason, move away from the food, then if they pass this distance, then the game is over. Number of trials is how many times you want to test each model. You can increase this or decrease this. This is the system message we're using, but you feel free to modify this to download the code. Maybe there are other system messages such as chain of thought prompting, which may actually make this work better. It says your goal is to find your way towards the food in a game. You will only be given the distance to the food. You can move the circle using the arrow keys. Please return each move. So we are asking to return a JSON object. This is so easy with GPT's JSON mode. The other models require a little bit of convincing. That's why the rest of the sentences. So we have a function to initialize agents. So if we have GPT and model name, we can initialize GPT calls with the model, JSON mode set to true, streaming true, max word history. This is the agent's memory, and we add the system message if it's Claude, and we initialize that, and we set its system message if it's Llama or Mistral AI. If you want to use Mistral models, we can also. I'm using Open Router, so this will require both OpenAI API key, um, Claude API key, and plus Open Router API key to use the router chat. Okay, just to clarify that point, I've added the API keys. It auto-detects from environment variables, or you can insert it here for OpenAI, Anthropic, and Open Router, and I've just added them to the initialization. Okay, after that, we calculate the distance. This is the distance we're going to calculate between the user circle and the food circle. And then we have a run game. We're going to initialize the distance list, and then we get our gamer agent using the initialize agent. And then we draw some Pygame specific stuff while true. So this is actually the cool part. I actually added an additional restriction. Let me actually explain with Xcolor. So we have this circle, which we are always, we don't see the circle, but we are working with a diameter. This is the green one is our user, right? That's the player gamer agent. And we have this pink food. We are always putting it along this perimeter, 100 pixels apart. But sometimes, for example, it will actually face directly the up direction, left direction, right direction, or bottom direction. So I actually put a restriction so that 60 degrees of this openings and cardinal directions are actually removed. So the food always appears in the diagonal. So the agent actually has to both move up, left, right, or left and up and down. So just to make it more difficult for the agent. So this is what we're doing here. Then that's the X and Y coordinates we're using. And we are running move. We set move to none because we're going to have the model return a move. We just want to initialize it, steps, set the initialize to 0, and then while running, we start the Pygame screen. We render the model name on the screen. And then here we calculate the distance, and we check if the distance is less than the circle radius plus the food radius. That means we have 1. I mean, the agent has 1, so we print to the terminal, and then we return the model name file, steps, failed, average distance, and all of that. So if we have moved, remember we set move to none. So in the first action in the game, in the first round of the game, we're not going to have a move. So our message to the model is going to be your current distance to the food. That's just that. But in the next iterations of the game, message to the model is going to be current distance plus your last move was whatever the last move was. So this is all the true information that it's getting, the distance plus its previous moves that it has made. So move dictionary is going to be just we're using the chat method of the unified classes that just actually gets a response, real convenient. And then when we have that, we assert that move is in the move dictionary. If this returns false, then we're going to run into an exception. Or if JSON.loads doesn't work, then actually we are going to try to remove if there's 2 user messages. This is for Claude, but it doesn't really solve the problem. If the model doesn't follow instructions, then we end up having a lot of user messages accumulated. But if you fail this, then we say invalid move, please return a valid move, exactly as shown in the example. So we want exactly this structure, can be up, down, left, or right. You must only return the move object and no other information, because sometimes 8 billion especially returns information and says like, oh, you found the food and stuff like that. But usually this actually fixes it. And interestingly, Llama 8 billion actually follows this instruction and corrects itself versus, for example, Sony wasn't doing that. So that's interesting to note. That's why I removed it from our list of models to test. But you can feel free to test any one of them yourself. So that's what happens, and then we check again if if the move is not in the dictionary. We do the same thing again, just double checking it, and then we just get the move from the move key, and then we just move the circle, increment the step, and if steps goes over the max steps that we have set, in this case 50, or distance is farther more than max distance we've set, the game timed out, then we return the model with the failed true, and a failure reason being max steps reach if steps, or otherwise agent went too far from forward. and the average distance. And we are drawing the circles and whatnot, calculating the distance, appending the distance. And here in the main, we are just calculating the results. We have this empty results dictionary for model and models. You're going to accumulate all of the results, and for trial in number of trials. So we have a loop within a loop, and we print whichever trial we're running for whichever model, and we are displaying the settings of the simulation, and the results is going to be the result of the run game, and we're going to append it both the model results and all results, and then we are going to save these files, this Claude 3 Opus results file, for example, or GPT-4 Turbo results file, things like that. And then we're going to save it. In the final results, we are going to actually calculate the model results. Now, for modeling models, we're going to get the model results, successful trials, total steps, number of failed, average steps, and we calculate the average distance. Otherwise, NA, same for average steps. If all trials have failed, we input NA, such as if you look at 8 billion, see if you look at the final results for 8 billion, okay, it was at the top, then average steps is NA. And then we append this to the final results and we write it. And then we sort the results and write it like that to all results. So if you go to all results, you'll see this is sorted by step. So if you wanted to decide who the winner is based on the minimum number of steps, then GPT-4 0125 and 1106 actually is the winner. And then next after that is the latest GPT-4. And then the close second, as far as like different large language model, then Claude 3 Opus. And after that is the Llama, 70 billion. Yeah, so we save that. And then at the very end, so all these files are going to be saved in your working directory, but at the end, we just move all of them to a properly named folder. For example, we use 50 megs steps, 5 trials, 100 megs memory, and 150 megs distance. Yeah. So if you were to run this with different configurations, they should all be saved into separate directories. Like I said, these code files will be available at my Patreon along with the results. Yeah, thank you for watching. This was the end of our video, but I'd like to talk quickly about my OptiStreamer version 3 project. OptiStreamer version 3 is a PyQt-powered PyInstaller packaged Python project that I came up with. It uses your OpenAI API key to create course websites such as this one in real time. This is also deployed at Railway, and including with audio.
The elif clause. In Python.
So you have quite a lot of choices, such as 6 different voice choices and over 50 languages that you can choose from. You can choose light or dark theme. When you go here to generate courses, you just enter a course that you would like to generate. For example, we just did permaculture basics, and I can pick how many chapters I'd like to generate, and I'm just going to go ahead and generate it real quick. This shouldn't take too long. Our curriculum was created successfully. I can go into view course outline and search for that, permaculture. And as I can see, ethics and principles, design methods and tools, and practical applications. I can then actually select this course outline and continue to generate the course in light mode. And then the website will launch automatically and will be created for you in real time. And you can record it as I'm doing right now, or actually live stream it. It's really up to you. And once it begins, we'll be able to
Ethics of care for the earth. Permaculture revolves around 3 core ethics, one of which is the care for the earth. This ethic...
I'm going to go ahead and pause it. If I were to let this run, then this entire course will be generated live, and I can listen to it live. I'm going to go ahead and stop. And if I were to let this course be generated, then it'll be under my view and launch generated courses. For example, I just created a course called Financial Basics for... Let's go ahead and launch. It's like this. I can actually switch to light mode as well, I believe. I'm sorry, dark mode. And then I can revisit this course. Both I can zoom in, both is in text and...
The importance of emergency funds.
Yeah, it has 3 chapters, which I can easily use. The benefit of this and what you'll get out of it is that instead of chatting with in a disorganized manner, this allows you to create structured courses that you can run and listen to before you go to sleep, or just fill your time. When you have just 5 minutes or 10 minutes worth, you can visit these courses back anytime you like. So AutoStreamer, you can download a free demo from autostreamer.live. I'll put the link in the description. Mac version is coming soon. You can, if you click on the download free demo, it will take you to my Google Drive download. And these are the files you'll be downloading. AutoStreamerDemo.exe is the same thing as this, except with limited features. And if you wanted to download the full version, then clicking this will take you to my Patreon shop, where it's currently only for $200 instead of $300. You can read all about it in the website. You do need an OpenAI API key for this to work. And sometimes this is a PyInstaller package, the PyQt Python application. So your McAfee or Malwarebytes may flag it as not good, but as a matter of fact, all you have to do is just make an exception for the program. And if you have any questions, feel free to join our Discord or ask me the question that you have in Discord. Well, thank you for watching, and do let me know what you think of this project. I was really proud of this one. And like I said, the code files will be available at Patreon. And I also have special tiers for one-on-one meetings with me, if that's something you're interested in. And thank you for watching, and I'll see you in the next video.